Hi everyone, welcome to the Art of the Possible series. I'm Nihali Niyogi. I'm a principal cloud solution architect at Microsoft. This video is part of a playlist on integrated NVAs in vWAN, and more specifically, today we're going to talk about Checkpoint. With me, I have two amazing guest speakers, one of the top networking professionals that I have met in the industry. I have Cynthia Treger, who is a global black belt at Microsoft focused on Azure networking. And I have John Gao, who is the Cloud Alliance architect at Checkpoint. John has graciously offered to show us how Checkpoint integration works with vWAN. Cynthia and John, I have truly enjoyed working with both of you on this series and fine-tuning the content. Welcome, both of you. Main topic for today is integrated NVAs in vWAN. And I want to make sure that there is a big distinction made clear here, is that we have SD-WAN vendors. So you can see that we have partners that provide strictly SD-WAN connectivity, as well as, and these are the list of partners. And we also have partners that provide traffic inspection capabilities, north-south and east-west. And today's topic is going to be about Checkpoint CloudGuard, and John's going to walk us through that integration. And before we deep dive into Checkpoint, I'm going to have Cynthia talk a little bit about the differences between the indirect spoke model and the routing intent model in vWAN. So with that, over to you, Cynthia.
Thank you, Nihali. And hello, everyone. So this diagram is basically to represent what we used to do with Virtual WAN before routing intent was available, and the new architecture that we now have with routing intent. And the important message is to understand that both architectures are still relevant today. So first, on the left, with Virtual WAN and before routing intent was available, the only way to provide inspection between spokes or between spokes and on-prem, for example, was to add a security solution in a transit VNET and have the spokes cascaded behind that transit VNET. So that is represented on the left. So in each region, we have a virtual hub. Behind that virtual hub, a transit VNet with a firewall inside, and the spoke cascaded. Of course, with routing intent, now we have the ability to actually have the security solution directly inside the hub, simplifying the model and allowing to have the spokes again directly connected to the vHub. But because now we have routing intent, it doesn't make that previous indirect spoke model irrelevant. And the reason for that are many. So first, the first reason, for example, to still keep the indirect spoke model would be, for example, for a customer who wants to leverage a firewall solution that today doesn't have an integrated offer. So as you've said, Nihali, today, the integrated solution are, of course, Azure Firewall, along with Fortinet, Checkpoint, and Palo Alto. But should the customer rely on another security vendor, then the indirect spoke model would still be the only possible solution to have that integrated with Virtual WAN. Another solution is for the customer to manage the NVAs instead of having them managed inside the virtual hub, and for example, to be flexible in the horizontal scaling, for example, and manage more than the 2 instances that usually get deployed with a managed deployment. And the last solution is to address the number of prefixes that are advertised from Azure to on-prem and that today are limited to 1,000, for example, with ExpressRoute, The indirect spoke model offers a great way to actually provide a level of route aggregation, allowing to only advertise the spoke supernets down to on-prem. So routing intent makes it more flexible, easier to integrate, and of course we have managed NVA simplifying everything. We get the spoke-to-spoke direct connectivity back with routing intent. And so if this is what the customer wants, it's the perfect solution. But still, in some cases, the indirect spoke model may still be relevant.
Awesome.
So I hope that was clear. And
Yeah,
if you
awesome.
have...
Thanks, Cynthia. So, you know, with that kind of in the background, let me share where a typical customer would, what the starting point would be for a typical customer. So let's say I'm going to start here where a customer would have an existing virtual WAN, and I have created 2 hubs, one in the east and one in the west. And as you can see by this icon, it already has a firewall deployed. And if I go to the routing intent and routing policies, I'm routing all of the private traffic through the Azure firewall. Notice nothing in the network virtual appliance yet. And right now, my next hop is the Azure firewall, the integrated firewall. Now, at this point, I'll hand it over to John to show us what will happen when a customer brings in their own network virtual appliance, in this case being Checkpoint. With that, John, take it away.
Okay, all right. Let me share my screen here. So, okay, you should be seeing my screen now.
Perfect.
Okay. All right, guys. Yes. My name is John. I'm a Cloud Alliance architect, and happy to be here. So from here, I think from the 2 different architecture that Cynthia mentioned, right? So this is the routing intent architectures, and from our side, we're seeing, obviously we're integrated, so most of our customers are adopting to this specific reference architecture. But yes, the other reference architecture is still very relevant today. And they both have the pros and cons. And today let's focus on the routing intent architectures. So so what we're seeing here is a single hub design. So we have our Checkpoint NVAs installed directly inside the vWAN hub. And this is the absolutely perfect place to apply security, because anything that are connected to the virtual WAN hub, like our VNET, so our, obviously the VNET peering, customers have express routes or site-to-site VPN connections from the branch offices, and even the point-to-site VPN users. All these connections will get inspected by the checkpoints in the middle here. So essentially, so for the branch 1 to branch 2, right, that traffic will get routed to the checkpoints, right, and to the express route. So some customers may have multiple express routes connected to the virtual WAN. That traffic will also get inspected by the checkpoints. So, and also this is a brand new feature, and right now it's in limited GA for the ingress connectivity as well. So Microsoft deployed the external load balancer, having the ability to host applications also traverse through the virtual WAN hub here. So the application can be hosted in one of the VNet here, and customers will have the ability to publish the external IP addresses and connecting the applications from the internet. So this is single hub design. Now, what is different between the 2 architecture is that with the routing intent, essentially all the traffic will get routed to the internal load balancer. And then from there, the load balancer will then just distribute the traffic to the CloudGuard gateways, so Checkpoint CloudGuard gateways here, with a 5 tuple. So essentially, all the RFC19 addresses will get routed to the internal load balancer. From here, it gets to the checkpoints, and then these checkpoints are, we call it a cluster, but they're actually individual active gateways. And later on, I'll show you, how to go about installing this, and we can install up to 5 checkpoint gateways to provide that scale and throughput requirements from customers. So this is our single hub design, is the most popular. So any given a vWAN deployment with checkpoint, right? So this is what typical region or single hub would look like. Okay, so next, any questions here? Any comments from Cynthia and Holly before I move on to the SD-WAN? Okay.
So John, you mentioned inbound. Could you tell us a little bit more? How would that flow look like? So in other words, would the customer's workload be sitting on, let's say, VNET 1, and they can come in? How would that flow work?
Yeah, so during the deployment, right now the customer have the option of if they plan on hosting services, so they when they deploy the CloudGuard gateways, we have to deploy with the load balancer, right? So the first decision customer has to make is like, hey, do we have any external facing applications? If the answer is yes, we will deploy the external load balancer together with the CloudGuard gateways. Now, how the traffic will work is, let's say the user from internet, it will hit the public IP address that are attached to the external load balancer. Then the load balancer will then send the traffic to the next available CloudGuard gateways. Now, once the traffic hits the CloudGuard gateways, obviously we'll do the advanced threat prevention and inspection on it. And once it passes, then we'll send that traffic to the VNET client here, VNET 1 client.
I see. And that's the external load balancer that's displayed in this picture, correct?
Correct. Yep, that's right.
Okay. Yep. Got it. Thank you.
Yep.
Maybe one more comment, and probably something I haven't highlighted well enough just before, is that indeed with routing intent, so with the NVAs integrated directly in the hub, what is also possible is to provide, as you said, John, branch-to-branch inspection, which is not possible with the indirect spoke model. That's true. And also with the integrated NVAs in the vHub, we avoid extra cost of additional VNet peering because we have the spokes directly connected to the hub.
Yeah. Yeah, that's a great point. Yeah, that's a really popular use case. That essentially can also eliminate, right, the need for like a firewall appliance on-prem. And you can, as long as that let's say like a simple router will be able to connect to the virtual WAN, and we'll be able to provide that level of security directly from the hub. Okay, so let's move on to the next design, which is the SD-WAN. So this is another very popular design here. As Nahali mentioned earlier, we do vWAN Hub do have an integrated SD-WAN providers as well. So this is an integrated, SD-WAN provider installation inside a separate vWAN Hub. So in this design, both the integrated SD-WAN and also the integrated cloud security gateway can coexist in the same region. So on the left, we have a separate hub, a hub 1, and that will be installed with the SD-WAN gateways. So all the branch offices and potentially VNet as well will be able to connect to this hub, and traffic will flow between these branch offices through the SD-WAN gateway. And then on the right here, which is with the checkpoints, and obviously the same as the previous diagram. So anything that are connected to this hub will get inspected by checkpoint. Now access from these branch offices to the hub 2 connected spokes will go through the checkpoints. Now, there's one thing I want to highlight here, and we should take into consideration during the design phase is branch-to-branch traffic cannot be inspected by the checkpoints because all that traffic will be routed between the SD-WAN gateways to the branch 2. So that traffic cannot be inspected. Now the benefit of this is you obviously have the fully integrated SD-WAN NVA experience. So I'm going to pause here. Any comments from?
Yeah, just maybe to explain why we have two separate hubs, one for the integrated SD-WAN NVAs and one for the firewall NVAs. And that's because today in the same virtual hub, it's not possible to combine two different vendor solutions. So for example, we couldn't have in the same hub managed SD-WAN NVAs plus the managed checkpoint NVA solution, for example. And that's why we need to have them in separate hubs. Another solution that is also sometimes used by customer is for the SD-WAN overlay integration part, to have an SD-WAN gateway in a spoke of the virtual hub containing the checkpoint NVAs, and to use BGP, the BGP endpoint feature for the SD-WAN integration inside the virtual hub environment.
Yeah, that's a good point. Yeah, so yeah, you can do away with this design by installing the SD-WAN gateways in a peer VNet and using the BGP to advertise around. Yeah, that's also I've also seen those design as well for SD-WAN. Okay, so move on to the next design, which is a multi-region. So obviously, having the with virtual WAN, one of the very nice feature from virtual WAN is that obviously can install in a different regions very quickly, right? And having all the network services all integrated already from all the separate regions. And the link here is leveraging the Microsoft Global Backbone, so you get super low latency and a super easy to deploy network connectivity. So it's easy and fast, right? So the multi-region is it's something that's also very popular with our customers that has such a requirement, and also leveraging this low latency connectivity between the regions. And one thing I want to highlight here from a checkpoint perspective is that we recommend our customers to deploy a separate AS number. So the only thing difference in terms of deployment is that you make sure you select a different AS number, because if in the future down the road, if you need to support site-to-site VPN, or when we start rolling out our integrated SD-WAN solution, you have to have a separate AS number in order for a routes to exchange. So there's something I want to highlight here from a checkpoint side. Any comments here? I will move on to another design that we have in place for the for vWAN is we also support site-to-site VPN. So obviously, customers can terminate their point-to-site or site-to-site client-to-site VPN to the Azure point-to-site VPN gateway. So we do also have customers who prefer to use checkpoints to terminate the site-to-site VPN. So let's say they already have an on-prem checkpoint install base with all the VPN clients already installed on the laptops. So, and for the customer who wants to move to the cloud and will move to virtual WAN, we also support that VPN connectivity as well. And actually, we made it much more scalable by integrating with the Azure Traffic Manager. So essentially, how this solution works is we add all the regions, all the CloudGuard Gateway public IP addresses to the Azure Traffic Manager, and the Traffic Manager has the ability to monitor our security gateways, right? So obviously, doing the ping test, doing the port monitoring, making sure that when a user is connecting to, let's say, US East, for example, the gateway is available. Now, what's cool about the Traffic Manager and what makes this solution very scalable is it has the ability to detect where the users are connecting from. So let's say the user is connecting from Australia, and when they run a DNS query to the Traffic Manager, say, hey, connect me to vpn.mycompany.com, for example, it will come back to the user with an Australia IP address. And the same for North Europe, right? So if you're in the region, it will connect you to the closest gateway. This makes the solution super scalable and in a very easily distributed environment. And once the user is connected, for example, to US East, for example, they can access, obviously, through the Microsoft Global Backbone, access all the resources that are hosted in Australia and also North Europe as well.
I just wanted to say that it's a really great feature to now have that possibility, because I think it's been missing until now, and customers could only use the VPN gateway for that, while they were leveraging VPN connection to checkpoint NVAs when it was not integrated in the hub. So I think that will be very welcomed by customers. Just one question, is there any limit in terms of number of client-to-site connections supported?
No, there is actually none. So for this design, it actually comes from a customer that has over 20,000 users globally. So we're able to scale out to 20,000 and more, right? So I don't have the performance numbers in front of me right now, but we can easily handle 20,000 because the reason for that is inside the virtual WAN, we are able to deploy up to 5 checkpoint gateways per region. And obviously, we can actually deploy additional hub, right, with another 5. So it can scale up to as many users as you need to. So I don't want to put a hard number on it, but this solution is much very scalable. So we're very excited about this, and when we present this to customers, also very well received. Not only that remote VPN connectivity, but also the checkpoint VPN client itself also has a lot of built-in security features that customers are looking for, like the anti-ransomware, like all the advanced blades that we install as part of our client, provide an extra layer of security and also connectivity.
Great stuff. Yeah.
Yep. Okay.
Thank
All
you.
right. Yep. All right. So next one, this is in preview right now. Site-to-site VPN support directly into the checkpoints. So again, in addition to the site-to-site the Azure VPN gateway, we also have the ability to terminate the VPN directly to the checkpoints now. And the design is an active standby, so we can leverage the obviously minimum of 2, right? So build in that resiliency. So even on-prem environment, you want to connect to the connectivity to the vWAN hub. Can leverage the site-to-site VPN. So this is something that we're pushing for Q4. Hopefully, we'll have this site-to-site VPN feature supported. Okay. Now this is this design here. What you notice that they all pretty much look the same, but what you notice that what I want to highlight in this slide here is the single hub design with the ingress and egress HA cluster, and this is to address a corner case, if you will, where some customers obviously will leverage the checkpoints for internet access, and then these checkpoint gateways inside the vWAN hub, their public IP address will not survive reinstall. So when you reinstall the checkpoint cluster, you'll have a new IP address. Now the corner case here is when some customers may have multiple business partners, and these partners will whitelist their IP address in order for them to connect to their resources, to the partner resources that is actually whitelisted by the IP address. So for customers who has hundreds of these business partners that they work with, whenever they need to update this IP address or when we install these checkpoint gateways, they will have a new IP address. So they will have to go and update, over 300, or whatever number, right, business partners. So from an operation perspective, it's quite a heavy lift, right, if they need to reinstall the checkpoint cluster. Now there is a solution, right? On the roadmap that we're able to help preserve this IP address, and until that comes, the workaround solution is to have a separate checkpoint cluster installed in a separate VNet that is peer to the hub. And because this is installed in a VNet, we'll have full control of the public IP address. And how this integrates here is that we'll have a BGP connection into the vWAN hub, very similar to the SD-WAN deployment that Cynthia mentioned earlier. We'll advertise those business partners' IP address ranges to the vWAN hub. So what happened is that, let's say VNet 2, VNet 1 client here needs to access the business partner. It will go directly to the internal load balancer here on the ingress cluster, and then from here we'll send it to one of the next available gateway, and then out to the internet. And you're connecting from an IP address that a customer has full control over. So this is to address a very specific corner case where those customers have those kind of requirements. So I figure I want to highlight here because this is something that we get asked quite often. Okay. And then one last thing for completeness is that this solution here is using our older Harmony Connect solution, which is to provide egress connection for vWAN. So when vWAN first launched, we're one of the first security partners that integrate with vWAN. I think that was back in 2018, 2019 even. The integration at the time was to provide virtual WAN egress security. So we integrate at the time the Harmony Connect solution. So this solution is now, because now we're fully integrated in the virtual WAN, we are, this is solution now end of sale. And we actually changing change a brand new Harmony called Harmony SASE now. So, but this particular architecture is going to be no longer relevant going forward. So for the customers who are watching this and you are using Harmony Connect, we advise to migrate off of the platform to a more integrated solution, such as directly into the virtual WAN. Okay. All right. So that is the reference, all the reference architectures. Any comments, questions before I show you guys a quick demo how to go about installing these checkpoint gateways into the virtual WAN? I'll show you guys how to onboard that to the management station as well. Okay. All right.
Sorry, I thought
Yeah.
of something. So if you go back to your, I think it was slide number 9, John.
Mm-hmm.
So here, when you have the multi-region architecture, let's say the VNET, prod VNET on the left from the East Hub, talking to prod VNET on the right, the Australia East Hub, would that traverse the checkpoint twice?
Yes, it will. So the traffic will hit the load balancer once it crosses a region. It will still have to hit the internal load balancer here. So
Internal load
it's double.
balance. Yeah.
Yeah, it's double inspection.
Double inspection. Okay.
Yep.
Okay.
So yeah, because if it goes direct, then we'll start having asymmetrical routing because the reply packet will go back here. Yeah.
Exactly. And
yeah.
yes, and this is how I believe our Azure firewall, the native as the secure vWAN hub works as well. So, and then again, just going back to your slide number 12, just so I have that concept clear. So here the corner case you mentioned was more for egress, right? The outbound IP.
Correct. Egress. Yep.
I see.
Yeah. Because for internet, so let's say without the ingress cluster here, right? All internet connection going out will go via the external interface of the CloudGuards, and this external interface is tied to a public IP.
Yes.
And then once the cluster is reinstalled, right, we'll pick up a new set of IPs. And because of some of the customers, business partners still using IP address as an level of access control into the resources. Our customers will have to call the business partner and say, "Hey, I'm connecting from a new IP. Can you please add these IP address?" And that usually requires a change control ticket. And for the customers that has over hundreds of these partners, it's quite an overhead. So
would ingress have the same issue though? Would ingress traffic also would have to be taken care of? Or okay, so that's how.
No, ingress, yeah. So ingress, yeah. So this design previously was able to address the ingress connectivity as well, right? So this is before we implemented the external load balancer inside the vWAN hub, right? So the team at vWAN team has worked very hard to integrate the load balancer into the hub so that we're able to cater for the ingress connectivity. But this design also works for ingress as well. Don't get me wrong. It's also, we're able to cater for the ingress. Again, customer will have full control of the IP for ingress connectivity. But I think now with the integrated ingress connectivity, right, this is the preferred architecture as opposed to, having the ingress go through the separate cluster.
Got it. Thank you.
And one more question on this design, John. This means we need additional NVAs in the spoke then?
Correct. Yeah. Yeah.
Okay.
Yep.
I have one more question.
Yeah.
Sorry,
sure,
I have. Yeah, sorry.
Sure. Yeah.
Just wanted to clarify on how many instances were deployed per managed deployment in the hub.
The instance is up to 5.
So one deployment can go up to 5, and that correlates to the number of scale units we select when doing the deployment, correct?
Yes, that's right. Yep.
And how does that scale in terms of bandwidth? Because one thing I noticed with customers is that when they do the deployment using the portal or basically by selecting the scale units, it comes with a bandwidth, but that bandwidth applies at the VM level. And then, of course, there is some bandwidth consumed by encapsulation, encryption, etc. So do you have sort of values between the bandwidth provided by the scale units by the underlying VMs and the effective bandwidth we get at the OS level?
We do publish the performance numbers, but we don't publish the performance numbers per NVA. It's really a combine, right? And that is we actually published that during the in our ARM templates during the deployment. So we'll have those numbers next to it. I'll show you. This is a good segue into the installation process. So we do have those numbers published, but it's not per NVA. It's actually per the entire scale unit. So and I'll show you that during the installation process. And obviously because this is an integrated NVA, right? So for the customers that wants to upgrade to a larger throughput cluster, that they can do that, right? And it's really just a matter of routing intent change from the old to the new. I'll walk you guys through that right now. So to install the checkpoint NVAs, there are a couple ways, 2 ways. You can go directly into under the vWAN hub here, right? So under virtual WAN, select the hub that you want to install you install, and then under third-party providers, third-party virtual appliance, you can add a new NVA here, right? Or the other way is through the Azure Marketplace to run a search for CloudGuard Network Security. Once you find it, go through it will take you to the same place. So I'm going to go this way, go add a network virtual appliance, and then select the checkpoint. Go to create. Yes. And this will take you to our marketplace offer. Okay, click on create. Okay, so I'll go through some of the basic stuff here first. Not that. I install what's going to install in West Central. So give it a so here to select, I just select the resource group where my hub is located. Select the region, and then I'll just give it the application name. So we're installing as a managed application. So now we can go next. Here, it'll detect that, hey, I do have a hub here in West Central. Select the vWAN hub. Give the NVA name. Now, Cynthia, I think this will help answer your question, is that behind each scale unit, how much throughput am I expecting to achieve at the maximum throughput? So we have different numbers of performance numbers, and this is actually NGTP contains all the advanced threat prevention features that we can deploy. So this number here, 40 gigabits per second with 80 scale unit, is contains like with all the advanced features turned on, right? So you expect to able to achieve up to 40 gigs. Now, for the customers that only wants to run firewall, this number is a much more much bigger. Obviously, without all the advanced threat prevention overhead. Does that answer your question, Cynthia?
Yeah, thank you. And I'm actually happy to see that we have the effective value we get at, the firewall level, because I remember some time back, it was, at least for SD-WAN and VAs, it was the bandwidth of the underlying VM. So yeah, I think that makes it much clearer. Thank you.
Okay, yeah. So in our case, for testing purposes, I'm going to select 2 scale units. And I'll generate a new key pair, right? So just give it a name. Okay. So next this is very checkpoint specific, right? So we have a different pricing model, right? And our pricing is based on per gig process traffic. So we do away from the per core license what we used to charge customers. So we change our licensing model to align to the vWAN licensing model, which is per process gigabits. So we're gonna select NGDP. So we here just give it a name, a SIG name. So this is just the internal trust, the initial trust that we need to set up between our firewall to our management station. And once that is done, we'll obviously have a fully encrypted between the NVA and our management station. The Bootstrap script is useful for customers who have very specific configuration for their environment. So if you want to, if customer wants to, let's say, SNMP or like NTP or, some specific configuration that, when they want to incorporate as part of deployment, you can include that here in the Bootstrap script. We're not going to do that now. We also have our SmartOne Cloud, which is management as a service. So a customer who wants to who don't want to run their own management server, they can deploy that directly. We can integrate that directly into the SmartOne Cloud, which is a firewall as a service integration. So we're not going to do that here. And then this is the ingress, right? So for customer who wants to run the ingress, they can, right? So they can select, hey, let's go ahead and deploy the external load balancer because I want to host applications in my vWAN. So you would deploy that here. So, and that is pretty much it. And once you click review and create, we'll go through the installation process. It will take about anywhere from 5 to 10 minutes. Once we finish install, right, you will have a brand new managed application. So I'm going to fast forward here for the sake of the recording and presentation. So I've already installed a cluster. It's under the third-party NVA. So this is a Microsoft demo firewall, and I can get the instance information directly from here. So I will take this IP address and I'll onboard this to my management station. Okay, so this is the NVA information. I also want to highlight, it's a managed application. So how do I go about deleting this, right? If I don't want to use it anymore, how do I delete this, right? So it's actually under managed application. So from here, you just select this and go in and you'll be able to delete the managed application from here. Okay, so, all right. Now, I'm going to go ahead and onboard one of the gateways to the...
John, quick question. On that screen where you created the appliance, do you still have the Create Cloud Gateway still open or up at the tab?
Under the third-party NVA?
Yes, so the
Okay.
first tab you have in the browser, is that still create? Yeah, this one. So this SIC key, how does that get created? Is that something the customer would create, a checkpoint creates? Where do we get that key from?
Oh, yeah. So this key is SIC stands for Secure Internal Communication. And this is something that customer will have to create initially. So it can be anything. It's just a passphrase, if you will, right? It could be today's day, or it can be anything, right?
I see.
As long as but that being said, you have to remember this key when you onboard our gateway to our management station, because it will use this key as a way to authenticate itself for the first time to our management station. And then afterwards, we'll use our, obviously we'll have our internal CA, and we'll start encrypting that connectivity to our firewall on
I
management
see.
station.
Yeah, first time I saw it, somehow I thought it was like a license key or some sort of a key that needs to be generated by the checkpoint portal.
Mm. Yeah, it could. It's just something customers will
Will
define
create.
initially.
Yes.
Yeah.
Okay. Perfect. Thank you.
Okay. All right. So once this is created, again, I'll onboard one of the gateways. Okay, so under third-party appliances, NVA information. So I have let's say, I'll just onboard one of them. The same process you follow for the other one. Okay, so what you're looking at here is the Checkpoint Smart Console, and this is our central management station. So we have under the Gateways and Servers tab, go to, and these are all the firewalls, right? So these are the firewalls that are currently under management of this management station. So I'm going to onboard one of the gateways. We'll select CloudGuard IS, plug in the public IP address. Okay. Go to next. So this is the one-time password. So this is the SIC key. Okay. So once I click next, the management station will reach out to the firewall and to establish that initial trust between the management station and the firewall. And then from there, we'll leverage the internal CA as for encryption. So that's it. So now that onboarded one of the Checkpoint CloudGuard Network Security gateways into the management station. Next, and that's it. And from here, we will obviously disable some of the anti-spoofing we'll go and disable the anti-spoofing on our interface. And the reason for that is that, because of how routing is done in the cloud, the firewall will get very confused, start seeing IP addresses coming from hey, you're not supposed to coming from this interface, so we'll have to go ahead and disable the anti-spoofing. And once that's done, press OK. Then we successfully onboarded the gateway to the management station. Next step is to apply a security policy to it. So here I already have two firewalls already onboarded. So I'll go through that simple security policy that you need to create for connectivity to work. So 4 security rules. The first one is to make sure that we have a management rule from a management station to the firewall, right? So that we won't lock ourselves out. That it does happen, and after like 20 years of firewall experience, I still lock myself out sometimes. So it's always good to have one of these rules in here, so to make sure that management station and the firewall will not be blocked. And then these 2 rules essentially allowing all the RFC19 addresses to talk to anybody, right? Obviously, very permissive in live environment. And one last thing I want to highlight from a policy perspective is that you want to disable NATing, right? So you don't want to NAT the traffic for the internal traffic. So I suggest to create a no NAT rule, and this is the two network groups that contains all the RFC19 addresses, so that connectivity between the networks, right? VNET, so VNET and VNET to express route, right, will not be NATed. And then this one here is for connectivity to the internet. So we have all the internal networks to the internet. We'll do a high NAT behind the checkpoints. And this is actually a dynamic object. So because we can install up to 5 gateways, so it will always use local gateway external IP addresses for egress. That is pretty much it from a policy perspective. And then for the customer who wants to enable advanced threat prevention capability, right? We have we implemented a super easy to call security. It's called the autonomous threat prevention. So, obviously, me being a network person, I don't have I'm not up to speed on all the advanced threat prevention capabilities from Checkpoint. I just simply enabled autonomous threat prevention. It will apply the best practices policy for sandboxing, for CNC connection, for the threat cloud, for IPS, and all the advanced threat prevention best practices from Checkpoint, from all the experts across all these different domains here, security domain, applied on this security gateway. So the autonomous threat prevention. So if you want to enable that, just click a button and we'll have all the advanced threat prevention capability installed or configured. So that is my demo. Any questions before we wrap up the demo part of this? Okay.
John, I have a quick
Yeah.
question. Could you take us back in the portal into the resource group where we deployed the appliances?
Resource group appliance. Okay, so there are two resource groups. So one is for the virtual WAN and one is actually specifically for the managed application. So which one? I can show you both.
Yeah, let's look at both. Where does the CG get deployed? The CloudGuard.
Okay, so this is the so this resource group is the managed application resource group. This gets created when we install the managed application, right? So this is when we install the CloudGuard gateway. So this resource group is for the managed app, and inside of it, we have obviously the identity. This identity is used for talking to Azure. So at the NVA level, we'll be using this identity to talk to Azure, such as reporting the consumption or running queries, various different queries into Azure, such as getting getting really down to the weeds here. This identity also helps us read the Azure configuration, such as getting the vWAN BGP endpoint so that we can automatically configure BGP on these gateways, right? So we use this identity. So this is the managed application resource group. And then we also have sorry, any questions here, Holly?
No, that makes sense.
Okay. And then we also have a resource group for the virtual WAN itself. So here, this is all my labs, so it can be a kind of mess, but so this is the resource group for the virtual WAN. So obviously we have a vWAN, we have our NSGs and public IP addresses, etc. here.
Nice. And those are the public IP addresses for the CloudGuard, right?
Actually, this public IP address is for the load balancer.
Oh, right. Yes.
Yeah.
Okay.
Yeah.
Yes. For the ones
CloudGuard,
for the ingress that we built.
Correct. Yes. For
I
ingress.
see.
Yep.
And so my question was, the first time you accessed the, when you were onboarding it and first time you accessed it, was there a rule that allows your smart console and then you added the management rules, the management policy?
Yeah, so the first time after the NVAs are installed, it will sit there and wait for the management server to talk to it, right? And then and because it doesn't know where it's connecting from, so that's why that secure internal communication key, the one-time passcode, is super important
I see.
to have.
Okay.
Yeah, otherwise, we can have other folks managing for us without us knowing. So
So routing wise, it's allowed from anywhere, one sitting, like anyone running the management workstation with that key can access it.
yes, that's right.
Okay.
Yeah. once it's onboarded, obviously, you know, we'll
You set
apply our
the
security policy to it.
yeah. Yeah, I saw you applied the policy right away. But I was curious what happens the first time. So that SIC key is, like you said earlier, is critical. Quick question here. The cost for the infrastructure, is that integrated with the Azure cost center?
Yes, that's right. So as the customer install the managed application, that will show up as a line item in the under subscription costs. You'll be able to see that directly from there.
Got you. Thank you.
All right. With that, I think you know which you know, this wraps up my portion of it. You know, we're super excited, and you know, we're working with the Azure Virtual WAN team, and obviously, you know, with the folks, you know, Lahali and Cynthia here, to promote this solution. You know, this for us, this has been you know, we have a lot of traction behind this. A lot of customers are showing interest because it's just really easy to deploy the firewall services in the virtual WAN, and you know, obviously with all the integrated network services in the vWAN, you know, the customers are very pleased, you know, running the solution. So so with that, back to you, Nahali.
I actually have a question, John, and
Sure.
I think your wrap-up is perfect for that. Maybe, you know, just clarify one more time what a managed offer consists in compared to like manual deployment we would do in a standard VNet. I'm not sure we've gone through it, so definitely automatic deployment of VMs that the customer doesn't have to select. And I don't know if you want to explain how it differs from manual deployments that we would do otherwise in Azure.
Sure, yeah, happy to. So the question is, what is the difference between the managed the integrated and managed deployment as opposed to the design that Cynthia highlighted earlier with the hub and spoke model? Now, the two, there are a few, like, you know, the main advantage for me, right, and our customer, what really help customer resonate, really resonate with customers, sorry, is that fact that with the routing intent, the customers can easily switch between the versions of the CloudGuard gateways, right? So and it makes it very easy, right? So instead of having, so in the hub and spoke model, it's an IS solution, right? So customer will install the NVAs, will have to obviously, you know, onboard it and get a policy on it, and then also to advertise the peer subnets to BGP, right? So that's another set of configuration that customer has to do outside of the fully integrated solution here inside the hub. So obviously that solution works great. In terms of if your customer wants to upgrade, for example, right, from the hub and spoke model, is that they will have to install a separate cluster, have to all the VNet peering separately, and also migrate the VNets over. Okay, so from an operation perspective, it's much more overhead. Now, changing over to the integrated solution inside the hub, where Azure is actually number one, right? Azure is taking care of all the routing for you, right? So whenever you have a new VNet attached to the hub, that VNet will get advertised to across, you know, across Azure, right? All the different regions that you may have deployed, all different hubs will have that new VNet IP address appear. Whereas the old solution, you have to manually and add that VNet IP ranges to the vWAN hub to advertise as subnets, right? So that's number one, right? So that from a day-to-day operation perspective, it's much easier to have the integrated solution. The other benefit of this solution, I suppose the other one, is that customers can simply deploy the cluster here and leverage the routing intent feature and route all the traffic to the checkpoints, right? So it's literally a few clicks away for the traffic to be to get inspected by checkpoint. And because of that, customers can also leverage the routing intent feature to change between versions, right? So traditionally, you know, being in the firewall business for like 20 years, upgrading firewall is not always easy, right? And it can be quite challenging. And using the routing intent feature, Checkpoint is about to release R82 version, which is a new version of Checkpoint, right? I want to use that feature, so what I can do is I can install another Checkpoint cluster inside the vWAN hub, right? So side by side. So I can show you an example here. You can actually change between the two versions using routing intent. So this, just thinking back, so if I had this feature, like, when I was still managing firewalls, like from an operation perspective, I can actually change from the old to the new with a simple click of routing intent, right? And this, usually takes about anywhere from 5 to 15 minutes. So my change window, right? Number one is that, I can have a simple, small 15-minute windows change from the old version to the new. And if anything goes wrong during the change window, during UAT, for example, I can always simply go in here and switch back to the old version where I know, right, 100% it will work. So the routing intent feature, and it makes it so much easier to manage firewall in terms at least from a networking routing perspective.
And from a deployment perspective, because you don't have to deploy the load balancers, they will be deployed automatically under the hood.
Yes. So, well, actually, both solutions we will include the load balancer as part of an ARM template. But the benefit of this is obviously we don't have to deploy in a separate VNet and do all the peering again, right? So there's a lot of moving parts in that, which can impose quite a significant risk to the network. So yeah, this is definitely a big game changer, from in our opinion, and again, it really resonate really well with our customer.
Okay.
Excellent. Anything else? Any other last thoughts?
No, thank you so much for having me, and it's always it's good to part of these sessions. So thank you.
Yes, thank you, John. Thank you for the demo, and it was really a frictionless experience to onboard those CloudGuard gateways. So thank you again, and thank you, Checkpoint, for your partnership. Thank you, Cynthia. Thank you for all your insights. Always a pleasure working with you both. Thank you, and until the next session.
Thank you.
Thank you.
Yeah, I'll pause the recording here now. Record and stop recording.